All right, let's talk about the area of a triangle. Now, you've probably memorized the formula, but have you ever really understood it, like why it is what it is? Today, we're going to crack that code. We're going to see how it's all connected to a shape you already know inside and out. Let's get into it.
Okay, so our journey starts with something super familiar, the good old rectangle. This is going to be our starting point.
So, you're probably thinking, what on earth does a rectangle have to do with a triangle? I mean, they look totally different, right? Well, that's the thing. The answer is the key to the whole puzzle. Just stick with me here because the connection is actually pretty cool.
Okay, first things first. Let's just refresh on something we all know. The area of a rectangle, right? The space inside it? It's just base times height. Simple. We're all on the same page with that. And believe it or not, that super simple idea, base times height, that's where this whole thing kicks off.
All right, now for the fun part. This is where the magic happens. This is that aha moment where it all clicks, and you see exactly how rectangles and triangles are linked.
So just picture that rectangle again in your mind. We know the whole thing has an area of base times height. Got it? Okay, hold that thought.
Now, what happens if we take a line and just slice that rectangle right down the middle, from corner to corner? Boom. Just like that, we've split it into two identical pieces. And what are those pieces? They're two perfect right-angled triangles.
Okay, so here's the big question. If the entire rectangle was base times height, and we literally just cut it into two equal halves, what does the area of one of those little triangles have to be? Just take a second and think about that.
Yep, it's got to be half, right? It's that simple. Each one of those triangles is exactly 1/2 of the area of the whole rectangle. No tricks, no complicated math, you can just see it.
And here's the coolest part. This doesn't just work for those neat right triangles. It works for any triangle. Every single triangle you can imagine is really just half of a parallelogram. And guess what? A parallelogram follows that same base times height rule, so the logic holds up everywhere.
Okay, so now that we've seen why it works, we're ready for the actual formula. But the great thing is, it's not going to feel like some random rule you have to memorize anymore. It's just going to make sense.
And there it is. Area equals 1/2 times base times height. See? It's not just letters and numbers now. It's literally half of a rectangle put into math terms. From now on, whenever you see A equals 1/2 BH, I want you to picture that rectangle with a line slicing it in half.
All right, so we've nailed down the why. Now let's get practical and do the how. Let's run through a quick example to see this thing in action.
So, let's imagine we've got a triangle. Its base is 12 centimeters, and its height is 7 centimeters. Easy enough. We have our two key pieces of information.
Let's plug these in. So, step 1, write out the formula. A equals 1/2 BH. Step 2, swap in the numbers. That gives us A equals 1/2 times 12 times 7. Now we just do the math. 12 times 7 is 84. And what's half of 84? It's 42. So our area is 42.
But wait, don't stop there. This is super important. The answer isn't just 42. It's 42 square centimeters. Remember, we're measuring the surface area, the space inside the shape, not just a line. So those square units are absolutely key.
Okay, before we finish up, I want to talk about the #1 mistake pretty much everyone makes with this. I call it the height trap. But the good news is, once you see it, you'll never fall for it again.
So what exactly is the height in the formula? Well, it's not just any old side of the triangle. The H stands for the perpendicular height. That means it has to make a perfect 90-degree angle with the base. Think of it like a flagpole standing straight up from the ground. It's not leaning, it's going straight from the base to the tippy-top point.
Yeah, check this out. A lot of times, a math problem will throw in the length of the slanted side just to trip you up. That's the trap. You have to learn to ignore that number. For finding the area, the only thing that matters is that straight up and down 90-degree height.
Okay, so let's boil it all down to 3 main takeaways. First, a triangle is always just half of a rectangle or parallelogram. Second, that's why the formula is A equals 1/2 base times height. It's literally half of the box. And third, the H for height is always the one that's perpendicular, the one that makes that perfect 90-degree angle with the base. And that's it. Now you don't just know the formula, you know why the formula works. You can actually see it. Which kind of makes you wonder, right? What other math rules that we've all memorized are actually just simple pictures in disguise, just waiting for us to connect the dots?